Welcome to SP Smart's NEET Direct program. Today we are going to discuss NCERT problems from the chapter of magnetic effects of current and magnetism, part first. So let's start from example 4.1. A straight wire of mass 200 grams and length 1.5 meters. So let me write the parameters. लिखा है कि mass कितना है 200 grams, which I can write so many kilograms. Okay, a length is 1.5 meters, as you can see here. Carries a current of 2 amperes. Okay, current is twice 2 amperes, right? It's suspended by in midair by uniform horizontal magnetic field B. What is the magnitude of the magnetic field? Well, idea is quite simple. There is a rod, all right, and इस rod के नीचे magnetic field लगाया गया है. That magnetic field actually is being applied to support its weight. That is, magnetic field की वजह से इसको upward force act करता है इस पे, and its weight is acting downwards. If the two are equal, only then it can be supported mid-air, जैसा कि यहाँ कहा गया है. You have to find the value of magnetic field that's being applied here. All right. As we know, weight is equal to F, और F होता है BIL sin theta. Here sin is 90, as you can see from the figure. Now what is the mass? ये value है. As you can see, it is 2 10 power minus 1. Already मैंने simplify कर दिया उसको. G को roughly 10 ले लीजिए. What is B? We don't know. We have to find out. What is current here? 2 amperes. What is length of the wire? 1.5 meter, जिसको मैंने यूं लिखा है. All right. You see, it is 3B here, right? Because ये 30 by 10 3 होता है. And on the left side, it is, these two get cancelled. It's 2. It is therefore 2 by 3 Tesla, 0.67 Tesla. This should be the answer to this problem. Okay, now let's move on to question 4.6. ध्यान से देखिएगा. A straight wire carrying a current of 12 amperes is bent into semicircular arc of radius 2 centimeters. Let me first write everything. Current is 12 ampere, as you can see here, and arc has a radius 2 centimeter, which I change to meters. It is imperative that we use only SI system. Consider the magnetic field be at the center of the arc. यानी इस डायग्राम की बात हो रही है, तो center of the arc यहाँ पे फील्ड कितना है ये आपसे पूछा जा रहा है. What is the magnetic field due to the straight segments? यानी straight segment कौन से यहाँ पे? ये और ये. These are straight segments. In what way the contribution of B from this semicircle differs from that of the circle loop, and in what way does it resemble? Would your answer be different if the wire was bent into a semicircular arc of same radius but in the opposite way as shown in the figure? यानी उल्टा कर दें तब क्या होगा, सीधा है तो क्या होगा? This whole picture that is we have to now decode. Yeah, it's a very simple problem. Magnetic field due to the entire loop, full loop, is mu naught I by 2r, right? And यहाँ पे B prime है और ये क्या है, उसका आधा, half of B, that is mu naught I by half का मतलब ये 4r हो जाएगा. So that should be there. So हम ये कह सकते हैं, now what we have is half of the semicircular लूप. यानी सेमीसर्कल लूप जो है ये वाला, इसकी वैल्यू अगर लूप फुल होता उससे आधी है. ये लिखा है, इन व्हाट वे द कंट्रीब्यूशन ऑफ बी फ्रॉम दिस सेमीसर्कल डिफरेंस फ्रॉम दैट ऑफ द सर्कुलर लूप. इतनी बात क्लियर हो गई. और बात सिंपल है कि वैल्यू या स्ट्रेंथ इसकी आधी होगी फुल सर्कल के कंपैरिजन में. सो लेट्स सब्स्टिट्यूट द वैल्यूज. म्यू नॉट होता है 4 पाई 10 पावर माइनस 7. करंट कितना है 12 एम्पियर, डिवाइड बाय 4. Radius is 2 10 power minus 2. You simplify it further. This 4 and 4 gets cancelled. You have 6 2 is 12. So 6 pi 10 power minus 5. ठीक है. So when you simplify this, it becomes 10 power minus 5. The rest is simple. It is 6 pi. Now you make substitutions. It is 6 into 3.14, 10 power minus 5. And how much is it? It becomes, on simplification, 18.84, 10 power minus 5 Tesla. If I simplify it further, तो क्या करेंगे? ये बनता है 188.4 10 पावर माइनस 6 टेस्ला, यानी 188.4 माइक्रो टेस्ला. दिस इज द आंसर टू दिस प्रॉब्लम. ठीक है, तो हमने इसके दो पार्ट्स कर लिए. इसका वैल्यू बताया था फील्ड का, फिर पूछा था इसका फुल सेगमेंट से हाफ का क्या वैल्यू है, वो भी हमने बता दिया. हाउ मच इट डिफर्स इफ लूप इज डन इन डिफरेंट वे, ये पूछा है. बेटा ये उल्टा लूप बनाने से कुछ नहीं होने वाला. इट विल नॉट मेक एनी डिफरेंस, राइट, एक्सेप्ट दैट इसमें जो डायरेक्शन ऑफ मैग्नेटिक फील्ड है इस वाले में, इट इज इनवर्ड इनटू द प्लेन ऑफ पेपर. मैं यहाँ क्रॉस लगा देता हूँ. क्रॉस का मतलब होता है इनवर्ड इनटू द प्लेन ऑफ द पेपर, जबकि इसका है डॉट. डॉट मीन्स आउटवर्ड फ्रॉम द प्लेन ऑफ द पेपर. इन शॉर्ट इसका क्रॉस है बी और इसका डॉट है बी. डॉट मीन्स कमिंग आउटवर्ड फ्रॉम प्लेन ऑफ पेपर और क्रॉस का मतलब इनवर्ड. बस इतने फर्क आएगा. स्ट्रेंथ ऑफ द फील्ड इतनी रहेगी जितनी हमने अभी डिराइव की है. ओके, नाउ लेट्स मूव ऑन टू प्रॉब्लम 4.3. राइट, इसमें लिखा है व्हाट इज द रेडियस ऑफ द पाथ ऑफ एन इलेक्ट्रॉन ऑफ मास दिस मच एंड चार्ज दिस मच. खैर ये तो स्टैंडर्ड वैल्यूज है, हमें पता होने चाहिए. मूविंग एट a speed of 3 10 power 7, तो लेट अस राइट speed of electron is 3 10 power 7 meter per second. Radius पूछा जा रहा है, व्हाट्स द रेडियस. हमें चार्ज पता होता है, विच इज हम जनरली क्यू लिखते हैं, बट यहाँ पे ई है 1.6 10 पावर माइनस 19 कूलम, और मास कितना है उसका 9 10 पावर माइनस 31 kg. ऑल राइट, and the magnetic field strength is given to be 6 into 10 power minus 4 Tesla. Perpendicular to it, that is theta is 90 degree. Very simple, it is Q by M into B होता है ओमेगा. ठीक है, तो ओमेगा यहाँ पे V by R होता है, बिकॉज V है R ओमेगा, तो अंडरस्टूड है कि ओमेगा V upon R is QM by B. So it is therefore mv by qb. बस आप वैल्यूज लगाना शुरू कर दें. मास इज 10 पावर माइनस 31 इंटू 9. वेलोसिटी इट वॉज गिवन टू बी 3 10 पावर 7. चार्ज ऑफ इलेक्ट्रॉन इज दिस मच एंड बी द फील्ड स्ट्रेंथ इज 6 10 पावर माइनस 4. ऑल राइट, 6 10 पावर minus 4. This is there. You now simplify it further. It comes to be so many meters, which is 26 centimeter. One part of the problem is over. Next क्या पूछा यहाँ पे? Next करा गया है what is the frequency? Frequency, well, omega is 2 pi nu. तो न्यू हो गया ओमेगा बाई 2 पाई, और ओमेगा अभी भी मैंने दिखाया था ये फार्मूला क्यू बी बाई एम, तो क्यू बी बाई एम, तो ये बन गया राइट. ये फिर पहले की तरह आप सिंप्लीफाई करें वैल्यूज. क्यू चार्ज 1.6 10 पावर माइनस 19, और फील्ड स्ट्रेंथ जैसे कि यहाँ दिया गया है 6 10 पावर माइनस 4, 6 10 power minus 4, 2 pi mass of electron 9 10 power minus 31. You simplify it further. Then it comes to be 2 into 10 power minus 6 hertz, 10 power positive 6 hertz, which is 2 megahertz. So this is the answer to the problem. And the last part of the problem, calculate the energy in kilo electron volt, how much energy it possesses. Well, in a magnetic field, the only energy a charged particle possesses is the kinetic energy. Okay, so we can write that kinetic energy is half mv square, half m mass of electron 9 10 power minus 31 velocity was given to us 3 10 power 7. All right, it is 3 10 power 7. So it is 4.5 into this into minus 24. That you can check out yourself. ये आ रहा है. Now it has to be in electron volt, or rather kilo electron volt. So this much value that I got is in joules. Now we know 1 electron volt is 1.6 10 power minus 19 joule. So joule को convert करना है now in electron volts. What do you do? You divide this value that I've just calculated by 1.6 10 power minus 19 because of this expression, and see what you get now. So on simplification, it gives us 25.3 10 power minus 5. Further, let it be 2.53. decimal मैंने change किया place so that this now becomes, which turns out to be 2.53 10 power 3 electron volt, that is roughly 2.5 kilo electron volt. So this is the kinetic energy of the particle as discussed in this problem. Since this is a very lengthy numerical, let me show you in brief the entire calculation. This is formula for radius, gyro radius of a charged particle in a magnetic field. When you put all these values, you get an answer 26 centimeter, as we have got here, this 26 centimeter. Okay. Then it is velocity by circumference 2 pi r is nu, and this is 2 10 power 6, that is 2 megahertz frequency, and this is what we got, 2 megahertz frequency. And the third part is half mv square is kinetic energy. You put in the values, you get 2.5 kilo electron volt, and here also you find 2.5 kilo electron volt. All right, so in short, this purpose of entire lengthy calculation was only to elaborate each and every step. Otherwise, you can, by putting straight formulae, you can solve all these 3 steps in a very short span of time. So in this way, we have been able to solve NEET Direct NCERT problems for today from the chapter of magnetic effects of current and magnetism. And that's all for today. God bless you all.